Hello, students, and welcome back to Biology 101 lectures. This is the first module of the second topic. So this would be 1.2.1, Introduction to Chemistry. Often I get the question from students, why should I learn about chemistry? I signed up for biology. And we do have this very important unit here. It is critical that you do understand chemistry, and let's see if we can explain why. The first reason is that the laws that govern living systems are not different from the laws that govern non-living systems. If we were to learn enough chemistry, which, by the way, we will not, to do chemical reactions in beakers and things, well, those reactions could also take place in cells. And so the same laws would apply. The same basic ideas are here. And a second reason why we study chemistry in a biology class is because of this idea of reductionism. Reductionism is the attempt to understand the whole by looking at the parts that make up the whole. For example, if we want to understand a living cell, we look at what that cell is made of, and that cell, when we get down to it, is made of molecules and atoms, and these are the realm of chemistry. So we study chemistry to better understand biology. I also point out that there is this hierarchy in science. Chemists will make fun of biologists, saying how imprecise we are, and then, of course, physicists turn around and do the same thing to chemists. It turns out that physicists can, with great precision, describe the behavior of one particle. But if you give them a solution, such as is commonly dealt with in chemistry, physicists can't begin to describe it. And chemists kind of have the same attitude toward biologists, but the systems that biologists study are ever so much more complex than just a system, living organisms with trillions of particles interacting. And let's finally, why we study chemistry and biology is because you and all living things are chemistry. If we change your chemistry, we change who you are. If you're given a particular drug, it can temporarily or permanently alter your consciousness and the way you interact with the world. And so this is a pretty sobering thought, really, that you are something as delicate as chemistry. Let's look at some basic definitions. It turns out that everything in the world, so far as we know, is made up of elements. And so an element is a substance that is made entirely of one kind of atom. And all matter consists of elements, and matter has volume and mass. Therefore, we can measure matter. You should tie this back to one of the characteristics of science, and that is that science is materialistic. It's based upon the measurement of matter, and so that ties us back into science. There are, in the natural world, 92 naturally occurring elements, and they all occur in one of three states, either a solid, a gas, or a liquid. And if we want to know the difference between states, it's based on two primary characteristics. The first is the amount of movement or energy inherent in the particular substance. It could be a compound or it could be a pure element. So that's the first one, is how much the particles, the atoms or molecules are moving. And the second characteristic is the distance between atoms. And we can see that this slide uses the example of water that can occur in a solid form as ice, in a liquid form as water, and in a gaseous form as water vapor. And it is easy to see in these three panels that the density of the molecules increases as we go from gas, in which the molecules are far apart, into liquid, where they're more tightly packed, into solid ice, where they're more tightly packed yet. And if we could show the inherent motion, we'd see that the molecules in the gas would be moving like crazy, that in water would be moving a little bit, and that in ice would have some movement, but not very much. And so these are critical aspects of the difference between a solid, a liquid, and a gas. I would point out also that each of these 92 naturally occurring elements and the other elements which we've discovered which don't occur naturally, that is the man-made elements, that each is designated by a 1- or 2-letter chemical symbol. I'm not going to make you memorize the periodic table or something like that, but C stands for carbon and Ca stands for calcium, just for example. Later in the course, we will require you to memorize some chemical formulas, and so you would also have to memorize the chemical symbols in order to accomplish that. Just in concluding this introductory module, I'm going to ask you the question, what are you worth? And this is not based on a philosophical kind of platform. Rather, this is based on a chemical one. And if you weigh 150 pounds, all of the elements that make you up, if we could render you for chemicals, which in itself would be a fairly difficult purification process, you would be worth about $118.63. Here you can see the list of the elements which are in a human body. I would like you to notice that there are 3 columns. The first column here, for example, oxygen heads that column. That is the most abundant by weight element in your body. You have 43 kilograms, and that's just worth a fraction of a cent. And you can see that the units here are kilograms, the units here are grams, and the units here are milligrams. So the things which are very abundant in your body are oxygen, carbon, hydrogen, nitrogen, calcium, and then you get go down the list. And there you go. This is how we get the grand total of $118. In fact, a human body is worth much more than that if we harvest organs, for example, a cornea or connective tissue, harvest ligaments and things like that. In any case, with this little bit of trivia, really not that important, but kind of interesting to consider, we conclude our first module, and we will continue later.